Okay, I'm going to go over the beginning of the characteristics of functions worksheet. If you have not tried this on your own before watching this video, I want you to stop the video and try this on your own before watching my explanation. That's one thing that I miss with the in-class lessons is forcing you to think before I start telling you some information. And that's kind of how the beginning of this was designed. I wanted you to think about the lesson before I just started spoon feeding you information. All right, so it says, given the graph of f of x, complete each of the following, keeping in mind that we read graphs from left to right. Make sure to read everything. So it says, trace the vertex of the function in purple. So I'm going to switch to purple. I guess what I have right now is kind of purple. And then the vertex would be right here. And it asks, what are the coordinates of the vertex? So the vertex is at 4, 6. Next, it says quadratic functions change from increasing to decreasing or decreasing to increasing at the vertex. We are going to expand on that idea as we move through next week, and any function could change at a relative max or a relative min, and we're going to kind of start using that vocabulary. In this case, this point would be a relative max because it's the highest point in that region of the graph. It's actually the highest point on the function. A relative min would occur if the function was opening up. So the next part says, trace the increasing portion of the function blue. A function is increasing if, on an interval, if as you move from left to right, the graph is going upwards or moving up. The y values are getting bigger. So for this function, it is increasing here. It then says, for what values of x is the function increasing? And so we are going to use, we have to describe an interval of x values. And there's actually 3 main ways. I'm going to concentrate on 2 ways for today that we write intervals of x values. So the first thing is I know that if I look at 4, 4 is the highest x value. So it's all of the values of x that are less than 4. So that's one way of writing it. And this is probably the way that you are more familiar with. The other way, so this is what we call inequality notation. The other way is interval notation. Interval notation, is when you give the lowest x value and the highest x value for the intervals, and you kind of make it look like an ordered pair. So if you think about your x-axis, we know negative infinity is way over here, and infinity is over here. So interval notation for which the function is increasing would be from negative infinity all the way up to 4. And then I use parentheses for both of these because neither value is included on the interval for which the function is increasing. At 4, the function is neither increasing nor decreasing. Another way to talk about increasing is if you take any 2 points on an increasing interval and drew a line between them, the slope would be positive. And in this case, if I drew a line, let's just say at that top point, that would be horizontal. That's getting something into the idea of average rate of change versus instantaneous rate of change. And we're going to kind of talk about that this year, but it's really more of a calculus topic. The next question reads, trace the decreasing part of the function in red. Make sure I pick the right color. And that's this part. And then for what values of x is the function decreasing? It's all x values that are greater than 4 if I use inequality notation. And then if I want to use interval notation, we start at 4 and we keep going up. And now this is actually a place where students make mistakes a lot. Remember, we're giving x values. So I'm starting at 4 and going up to infinity. Because the function's technically decreasing, sometimes students want to put a negative infinity there. But that would be a y value. And that's actually kind of getting into an idea of end behavior, and that's actually what we're going to talk about on Friday. So I'm actually I answered both of those questions twice. I used two different notations. You can choose which notation you want. I tend to like interval notation. I tend to pick interval notation. It's just personal preference. The only time you need to be careful is if I ask for a specific notation, you need to answer it in that notation. And then you need to be able to read any notation I give you. Otherwise, pick the notation that works for you. Now, the next part says, trace the x-intercepts of the function orange. So we're going to switch to orange. So the x-intercepts are here and here. So my x-intercepts are 1, 0, and 7, 0. Now, something I want to talk about briefly, if I asked you for the zeros, so zeros are the values of x that make the function 0. They would be x equals 1 and x equals 7. At this point, we only have, we only know how to find zeros that are real zeros, and we're going to talk about what happens if they're not real later. So if I were to ask you for the zeros in this case, it would be 1 and 7. And then the next question says, trace the portion of the function above the x-axis green. So, sorry, my kids are coloring in the next room. So another reason why zeros are called zeros is they're not positive or negative. Those are the values where it's 0. So above the x-axis, the function will be positive. And it says to color that in green. So the function is above the x-axis. Here, I should have used the thicker pen. Let's use the thicker pen. So that is from the x value of 1 to the x value of 7. Then it says to trace the portion of the function below the x-axis, yellow. So I'm going to switch to yellow. And below the x-axis, I actually have two portions. So I have, remember, this side of the x-axis is negative infinity and this side is infinity. So I first have the values of x that are less than 1, or, notice that's an or, x is greater than 7. And that's a way to describe both of those intervals. To use interval notation, it would be negative infinity to 1, parenthesis, and then the set. So interval notation is also called set notation. And that U means union, which mathematically is or, 7, infinity. If you take some higher level mathematics, you might talk about set notation. So this symbol here means U, or it means union, or the math, or it's like or. The other mathematical symbol that means and. It's very similar to that, but we actually aren't going to end up needing it, I don't think, at all this year. So I will just stick with that one symbol to make your life a little bit easier. And then finally, the last question says, write the equation of the function in this form. And I'm actually going to do a couple of things with this question. I'm going to write it first in vertex form, and then I'm going to actually convert it to standard form just to remind you how to do that. So first, we have we know the vertex is at 4, 6, which means HK is 4, 6. So then I have f of x is equal to a times x minus h, which we just said is 4, squared plus k. Now the trouble is, we don't know what a is. So knowing the vertex tells us h and k, but we don't know the vertical stretch factor. So to solve for that, we plug in some other point that we know is on the function. So we know, and you can pick whatever point you know for a fact is on the function. We know that 1, 0 is on the function. So I'm going to plug in any point. I chose 1, 0. So the y value is 0. The x value is 1. Now I'm going to solve for a. So 1 minus 4 is 3, squared is 9. And I'm going to subtract 6. And then divide by a, which is negative 6 over 9, which is negative 2 over 3. So that tells me that my function is negative 2/3 x minus 4 squared plus 6. Now, although it's not asked for in this question, I want to show you how to expand that. So let's rewrite that question. Negative 2/3 x minus 4 squared plus 6. I asked you to write it in standard form. So standard form, we know, is y equals ax squared plus bx plus c. I just noticed my battery's starting to die, so let's plug this guy in. Maybe. So the first thing that we need to do is follow order of operations. So basically, we're just expanding this. So I'm going to make it negative 2/3 x minus 4 times x minus 4 plus 6. And then in math, we can only multiply two things together at once. So I'm going to start with x squared. And then I'm foiling. So minus 4x minus 4x. And then negative 4 times negative 4 is plus 16. Now I'm going to distribute that fraction. Negative 2 times negative 8 is positive 16 minus 32 over 3 plus. Now if you notice, everything's in thirds. So I still have this plus 6 out here, but I'm going to change it to 18 over 3, which we know is 6. 18 divided by 3 is 6. But that allows me to easily add it with the negative 32 over 3. So f of x is equal to negative 2/3 x squared plus 16 over 3x, and then negative 32 plus 18 is negative 14, and it's all over 3. So now this function is the same function as the original function, but I just wanted to remind you how to expand it to change forms. What I want you to practice now are the examples on the next 2 pages. One of them, the graph is given for you, or a couple of them maybe, and then you actually have to sketch your own graph before you can analyze it for one of them. Make sure you utilize the answer key so that you can check your work. If you have questions, please shoot me an email.